we want to find the domain and range of the following square root functions. To review, the domain of a function is a set of all possible inputs or x values, and the range is a set of all possible outputs, which should be the y values or function values. When working with square root functions, the main thing to remember is that the radicand, or the number underneath the square root, can't be negative, otherwise we'd have an imaginary number. So for the basic square root function, if x can't be negative, x has to be greater than or equal to 0, which would be the domain of our function. So we'll go ahead and express this using inequalities. X is greater than or equal to 0, or using interval notation, we would have the interval closed on 0 to positive infinity. These are the same intervals, one expressed using inequalities, and here using interval notation. Now to determine the range, we need to determine what are the possible function values, given this is our domain. Well, the principal square root of a number is always going to be non-negative or greater than or equal to 0. And therefore the range will be when y is greater than or equal to 0. Again, using interval notation, we'd have the interval closed on 0 to positive infinity. Now let's go ahead and verify this graphically as well. Here's the graph of the basic square root function. To verify the domain, we want to project this graph onto the x-axis. Notice how the x values would be when x is greater than or equal to 0 along the x-axis. To verify the range, we would project this onto the y-axis, but we do have to keep in mind that even though this graph is moving right very quickly, it also continues to move up indefinitely, and therefore the range would be when y is greater than or equal to 0. Let's take a look at the next square root function. We have g of x equals the square root of x plus 3. To determine the domain, we need to recognize that the quantity x plus 3 can't be negative, and therefore the domain would be when x plus 3 is greater than or equal to 0. Subtract 3 on both sides. We have x is greater than or equal to negative 3, which is our domain. Using interval notation, we'd have the interval that's closed on negative 3 to positive infinity. And now for the range, as we said before, when we take the square root of a number that's greater than or equal to 0, the result will never be negative. Therefore, the range would be when y is greater than or equal to 0. Using interval notation, we have the interval that's closed on 0 to positive infinity. And before we look at the graph, we should recognize that this function here is just the basic square root function shifted left 3 units. And here it is. To verify our domain, project this onto the x-axis. Notice how the x values are when x is greater than or equal to negative 3. And again, this graph does move upward forever, and therefore the range would be when y is greater than or equal to 0. Now let's take a look at our last function. We have h of x equals the square root of the quantity 3 minus 2x minus 4. Again, the radicand controls our domain. 3 minus 2x must be greater than or equal to 0. So if we have 3 minus 2x greater than or equal to 0, we would subtract 3 on both sides. Divide both sides by negative 2. And when dividing by a negative, we have to reverse the inequality. So we would have x is less than or equal to positive 3 halves. This would be our domain. Using interval notation, since x is less than or equal to 3 halves, the interval would be from negative infinity to 3 halves, closed on 3 halves. And now let's consider the range. We know that this quantity here is always going to be greater than or equal to 0, so the smallest value this would return would be 0. 0 minus 4 is negative 4. Therefore, the range would be y greater than or equal to negative 4. So using interval notation, we'd have the interval that's closed on negative 4 to positive infinity. Let's verify this graphically. Here's our function. If we project this onto the x-axis, notice how the largest x value is 3 halves. So x is always less than or equal to 3 halves. Projecting this onto the y-axis, The smallest y value is negative 4, as we said, and from there the graph goes up. Therefore, the range is y greater than or equal to negative 4. Okay, I hope you found these examples helpful. Thank you for watching.